Okay, friends, we're going to do a quick little unit analysis on this formula, which is the first one, and also the second formula. That one will be a little bit more involved, but this one's pretty straightforward. So we're trying to understand why, if you multiply a half times a speed in feet per second times a time in seconds, that the number that comes out should be in feet. So the idea is, why should this be feet? First things first, this half that's right here is not united. There's no unit on that. A half, if you've ever taken physics classes, which some of you may have, some of you may have not, there's a Newtonian equation for force, and half shows up in that. You don't have to know why. You don't have to understand where the half comes from. Just know it's just a number. So we can actually ignore this half because it doesn't contribute any units to the overriding result. How about this S? Well, the S units are in feet per second. So this guy right here is feet divided by seconds. I'll just use an abbreviation if that's okay. Feet per second. No unit here, so don't worry about that. T is time in seconds. So that's going to be time seconds, and if you like it, seconds over 1, if you want to keep the fraction a fraction. And then look what happens. The seconds divide off, leaving you with just feet, which explains why D makes sense to be measured in feet. Because if you take feet per second times seconds, you're going to have feet left behind. It's once again dimensional analysis. It never really goes away, does it? Let's take a look at the other formula, which is a little bit more involved, but I think we can still handle it. Okay, friends, here's formula number 2, which is breaking time. The first formula was breaking distance. And breaking distance depended on two things. How fast you were going and how long you were going that fast. Those two things put together give you a distance. You can think of it, some of you may have learned many, many years ago about something called distance equals rate times time. And that formula, the previous one, is basically a subset of that formula. But the time is interesting when you're braking, because the time, it's not as simple as just going a fixed speed for a long period of time. I often ask students, how long does it take you to get from here to Boise? And almost everybody says 6 hours from Bend to Boise, because they assume they're going about 60 miles an hour for 6 hours. That's constant velocity. When you're braking, your velocity's changing, and that's what's being measured here. Your constant speed right here is being edited by this deceleration force. And the units on that deceleration force are a little bit wonky. We'll get to that in a second. Time needs to be measured in seconds, according to what we just read. Speed is measured in feet per second. So the unit on this S, whatever this S is, that S is going to have a number, right? But that number is united. It's feet per second. And let me grab some blue chalk and actually make a little, make this fraction bar here stand out. So that speed is in feet per second. This force, this braking deceleration force, is in feet per second squared. Now, some of you might be thinking, wait a minute, that's ridiculous, feet per second squared. How do you square a second? We saw this a few weeks ago when we looked at Galileo's model for things falling on Earth. Things, when they fall on Earth, do not fall at the same speed the entire time they fall. They accelerate. So acceleration is a change in speed, which is what this is. Well, so is deceleration. It's a change in the other direction, but it's still a change in speed, and it's measured with the same unit. Now, if you're looking at this going, Sean, I don't feel so good. How does all of this turn into just seconds? Something you have to remember from way back in the day. You learned this when you were knee-high to a grasshopper. About the same time you were learning about fractions. And it's not crucial to remember this. If I say this out loud and you're like, I don't remember that at all, it's okay. It'll get us through this and it'll make sense as to why that has to be in seconds. You learned years ago that if you divide by a fraction, that's the same as multiplying by the reciprocal of that fraction. So for example, you take a pizza and divide it in half. You now have 2 pieces. Yes, each of those pieces is half as big as the original, but you have 2 pieces. Because 1 divided by a half equals 2. 1 pizza divided in half equals 2 pieces. Same pizza, divide in thirds. 1 divided by a third is 3. So the idea is, it logically makes sense that when you divide by a fraction, you multiply by the reciprocal. So let's use that here. You're dividing this by this fraction. So let's multiply this by the reciprocal of this fraction. So this is going to come down here, feet per second. That's the numerator. We're going to multiply it by the reciprocal of this, which is seconds squared over feet. Now, I'm going to grab my pink marker, or my pink chalk, I should say, and we're going to do unit division, which is the fun part of dimensional analysis. Some of you have said this to me. You like this part. So the feet divide off with the feet. And you see how there's 1 second here and there's a second's times seconds here? Well, one of these seconds is going to divide off by one of those, and look what's left. Just seconds. And that's why time is in seconds. Because the units say it has to be. Now that might not feel satisfying to you. It feels very satisfying from a mathematical perspective. And here's kind of the good news. Every single time you look at a formula that's got a combination of variables and these random little numbers thrown in, you'll see one later on in the lab with accident analysis, when they measure the length of the skid marks car tires leave behind at an accident. There's a really cool formula that can reverse engineer how fast the car was going when it hit, from the length of the wheel marks that were left. Those numbers all have units attached to them. And I think what so many people don't like about mathematics is the fact that they memorize formulas. And I was this way in physics back in high school. You memorize formulas, you plug numbers into them, you get numbers out, and you have no idea what happened in the interim. It's like a black box that numbers go into and pop out of, and you really don't understand. When you look at the units like this, all of a sudden it makes sense. Like, oh, okay, mathematically, seconds have to pop out over here. Even though these 2 numbers here have much more complex units than this one does, these 2 interacting with each other explain why t has to be in seconds. Okay, I hope that helped. Let's put them to use now.